So what is map time? It's a really funny name, right? And it's a hashtag all in one. So map time is literally time for making maps. It's also an internationally applied concept for mapping meetups. So the reason that we chose to do this workshop series as a map time meetup is because this way you will be already familiar with the map time concept. So if you go to, say, San Francisco and you see that they're having a map time meetup, you know you're welcome there. There's also one in Sacramento. So of course Davis needed our own because no one wants to ever cross the causeway. So we have one here. There's also one in Austin. There's one in DC. There's some in pretty much every country possible across the world. So that's why we picked map time, because we want to be a part of something bigger. We also want people from other map time chapters to come visit us if they are in the area when we're doing them. So Map Time Davis is our own special variety of map time, given that it's on a university campus. Different flavor than other places, like San Francisco tends to be very geared towards the startup community, where we tend to be a little bit more research needs oriented. And also our sponsors, the people that bring you map time, are pretty research oriented. So Map Time Davis is brought to you by the UC Davis Library's Data Management Program, Center for Spatial Sciences here on campus. We also have help from a lot of clubs on campus and other club type groups like the Davis R Users Group today. And also the Data Science Initiative provides our space for most of our workshops. So you can see this is a very, very much a group effort. We also, one of our goals, yeah?
What's the difference between the data management program and DSI?
Oh, that's a good question. Talk to me later about that one. It's complicated, is the short answer. Basically, I'll get to a slide in a second about what data management program specifically does, but we can talk more details later. So one of the things we like to do in our intros for map time is to tell you about another connection on campus, because map time is one of the main goals as we're setting this up, was to make sure that you knew you had a place on campus to continue learning about whatever it is we're talking about that week. So this week I'm plugging the Davis R Users Group. They tend to meet weekly in this space usually, right? So you can go to their website, you can get on their mailing list. Pretty low traffic. I highly recommend it if you are an R user. So be aware of that group. So a little bit more about the library's data management program. Our job is really to help you find, manage, and share data. So if you would like help with any of those kinds of things, you can come see me, or you can come see Vessel Ensberg. We have office hours separate from map time. So for GIS topics and spatial topics in general, Wednesdays from 2 to 4 in the Shields Library map room, which is down on the lower level, also known as the basement. So I'll be there on Wednesday afternoons. And then also same time in just the room just through this little door over here, you can meet with Vessel about general data management questions. So basically we're here to help you with those kinds of topics, and the DS side is more oriented towards data science and data processing, although I will help you with spatial data processing as well. So that's why it gets complicated. You can also see Pamela's back there. You can always talk to her too about the DSI. So about Center for Spatial Sciences, Alex. Go.
Center for Spatial Sciences, it's just a collaboration point for everybody at UC Davis that does something related to spatial sciences. So it's initially a bunch of professors who teach spatial sciences. We have a website, we have a mailing list, we help sponsor events, anything and everything you want to do related to spatial, come talk to us and we'll help facilitate.
Yeah, and you can start either with Center for Spatial Sciences or with me in the data management program, and we often exchange people who come ask questions because it just depends who's better to answer whatever, but whoever you start with is fine. Another thing that Center for Spatial Sciences does, I'm going to plug the geospatial email list. There's a bunch of us on campus that manage it, but if you're not on the geospatial email list and you like doing mappy type things, you should join. There are flyers on the table over here for how to do that if you are unfamiliar. Oops, this is the wrong slide. We're not doing cartography today, we're doing R. You know, I missed one. So normally I give you the list of what's coming up. We have one more this quarter, so next week we're going to be using OpenStreetMap data. So if you helped add OpenStreetMap data a couple weeks ago, now we're going to teach you how to pull down existing OpenStreetMap data and work with it. So that's next week. And we're currently in the process of scheduling our winter quarter. It's probably going to be at a different time because of the huge geospatial classes that are going on every afternoon next quarter. So we're probably going to move to a morning slot. So just keep an eye on that. We're trying to avoid scheduling during, there's 2 really huge classes that are going on, so we're trying to avoid those. Call for speakers. If you know someone or you yourself would like to give a workshop, we would love to have people present. So get in contact with me or Alex and we can set that up. Or if you know someone that we should talk to, let us know. We might have a Python person, crossing our fingers, for next quarter. Also, her name's a hashtag, so use it on social media. And then I've got my repo listed up there. I also have links in that repository to Ryan's repository, so either one you go to, you'll be able to find what we're doing today. So now we're gonna do a quick switch of computers to get started on the topic for the day. So in the meantime, look around the room, find someone new and introduce yourself to entertain yourself while we switch. Go, talk.
There are a few of these.
It's on the board right now. Either one.
So just, are you gonna get a minor JS?
That's fine. Yeah.
No, we're done.
Yeah, so I'm going back to show the special format. Yeah.
No, it's a good job. I'm surprised it's not working here because this is the thing that's coming. Yeah.
But the 2010 is the reference to the 2010 is in this format. Especially there's so much data in there. Specifically, it's like primarily utility, now that there's one where the format
Needs to keep the.
What were you gonna do?
Where are you from?
There we go.
Any social science data, we have to keep people on any questions. But you can always email me and I can make sure. Yeah. Just now for that.
Right, that's what I said. If you can't find the right one,
Yeah.
let us know because there's a bunch of other, like our user group, I bet there's like 5 other people per day.
Probably, yeah.
No topic.
You know, you have a lot. But even still, like, some of this looks like there's just like.
If you figure out how to do this and you want to go to a workshop, we'll have more people to listen about it because people always need this kind of thing.
All right.
Yeah.
Should we get started? Hi, everybody. My name's Ryan, and we're screencasting this hopefully on YouTube. So this whole thing will be available afterwards, probably on the DRUG website, and Michelle can link to that as well. And then this website that I'm going to show you and walk through resources is right up there on the board. ryanpeak.github.io, and then mapping_in_R. So let me escape out of this really quick. So I built a little website in R that has, this is by no means comprehensive. There's a lot of resources in R available. There's a whole website like Spatialorg, I think that Alex, rspatial.org, that Alex presented on recently. So I'm just going to try to show you a few things that I thought have popped up that I've found really interesting or useful. Maybe you will as well. If not, no worries. So the way this is laid out is essentially there's some fun GIFs and cartoons and things like that, but there's actually some hopefully useful material. And I think the main thing that I want to point out is that you can make 1,000 different maps and not all of them are going to be equal, nor are they going to be useful. One of my favorite Far Side cartoons is sort of this one showing they're building a moat inside of the castle because the plans were drawn up or read differently than they were intended to be. And maps are no different. Ultimately, we want to make a map that people can interpret easily, extract the data visually, and do something with it. And so they can be beautiful, they can be really aesthetically pleasing, but ultimately, if they're effective, a reader can just look at them pretty quickly and understand what you're trying to get across. So in saying that, I think one of the most important rules is keep things simple. And I think there's this really nice, this will roll back around, but there's this GIF that I found on Stat545. Jenny Bryan has a really great website. She links to this, and it's for figures, but maps are no different in showing what happens when you sort of start reducing, like here's all the bells and whistles that come, and what happens when you start removing things. Like if you remove the backgrounds, you clean up some of the labeling, because ultimately what you're trying to get across is the trend or the bar plot here. That's what you're trying to provide. And all the other special effects are distracting from that. They're not necessarily, providing anything. So suddenly you end up with a really nice, clean plot when you start removing a lot of the abstractions. And so I think maps can be similar. We can put a lot of stuff on there, but that doesn't necessarily mean we should. So having said that, there's a few hurdles to get through in mapping. I'm definitely not an expert in this. There's other folks, Alex, Nick Santos, and some others I would say are far more savvy in this, but projections and coordinate reference systems will consistently be something that you run into. And for those of you that have used ArcGIS, I know Arc does a lot of the same stuff, but I've definitely gotten shapefiles before from people that didn't have a projection, and there's this really fun guessing game of trying to figure out, like, okay, what is this actually? It plots somewhere in the middle of the ocean, and you're trying to transform it. So behind why we end up in that boat and how you can avoid it, hopefully, is there's sort of two different pieces of coordinate systems that we use, and they kind of merge and overlap in many ways. But there's geographic coordinate systems, which are really built on the Earth as a globe, right? So it's spherical, and it's wrapping something on that sphere or that ellipsoid, for that ellipsoid, depending on what kind of model you want to use. But it's spherical, so you end up using this. Coordinate systems are typically lat-long in degrees, right? Latitude, longitude. And you calculate things on geodesic or great circles around that. So that's geographic coordinate systems. Now, most things, although not most, I would say a lot of things use what's called a projected coordinate system. And that projection is basically taking that globe and flattening it, making it a flat surface. So it's retaining all the other pieces, but it's also sort of using different calculations to stretch that onto a flat surface, because then you can have a grid, right? You can calculate things on that grid, on that flat surface, and that makes it really, really useful. That's why we use these. But because there are so many, it can seem pretty overwhelming sometimes. I've just given a few examples here, but there are a lot of different ones. I would say there's a lot of great resources out there. I linked to one that I've found really handy. This one, this epsg.io. So if you go here and let's just type in NAD83, thing relating to NAD83, and there's tons, right? But if you look over here on the right, it gives you projected, geodetic 3D, geocentric. But if we wanted to, let's just look at the projected ones really quick. What I really like about this, let's pick Nebraska, is if you click on any one of these, it actually gives you a map showing where that is for, which is really helpful to quickly take a look. And then what's also really helpful is it gives you the attributes. So it's metric. Here's the coordinate reference system, CRS, NAD83. And then one of the things that you'll find that we use a lot or can use a lot is this EPSG, this code. The nice thing is there's a lot of functions in R, or spatial functions in R, that just need this code to give it this projection. So all you need to do is look up the code, and most projections have these, and then you're good. You don't need a lot of the other, there's things called proj4 files that have all this basically here contained in one long text string. But if you know the code, you're good to go. So are there any questions? That's a lot, I know, but this is just a really quick, we're gonna use those EPSG codes in a little bit. So anybody have questions about projections or which system we're using? No? All right. Feel free. Okay, so, yes?
It seems like one of the issues is that the projected coordinate systems have different boundaries.
Yep.
Not the whole globe.
Yep.
You have to know what the boundary is.
Right, well, there are projected coordinate systems for the entire globe, but there's also, like UTM sometimes will be in different zones. And so you could have a zone, it's all gridded, but for that given grid, when it's trying to stretch things onto that, it can only do it on one piece at a time. So yeah, if you have the wrong zone, you can sort of end up with, the problem is that there are so many of these that you can have, then they might look like the same, if you plot it, it looks, oh, that looks about right, but actually you might be off when you actually try to do analysis or calculations. So I would say that one of the first things you want to do is always make sure all your stuff is in the same projection. That will eliminate all of your issues right off the bat, is make sure they all have the same exact thing, because if they're different, things might not break until down the road when you don't really realize it. So anyway, that's a good question though, yeah.
And on the other hand, geographic coordinate systems are usually universal, like just lat long, so you always know where you want to be. They hopefully
I would say the same. I would give the same answer actually, because you could have different. Yeah, do you have a?
I can clarify this a little bit. So projected coordinate systems don't have a boundary per se.
Right.
But if you say use UTM zone 10,
right,
and you apply it to someplace in China, you're going to have a lot of. So 10 is one of the California ones.
Right.
So if you try to apply it to like China data, you're going to have a lot more distortions.
Right.
The area of minimal distortion would be like California.
Right.
So if you try to use it for someplace else, you're going to get a lot of distortion. If you use just a geographic coordinate system, it's just latitude, longitude, everything is distorted. There's nothing preserved. So you don't want to use that if you're trying to make measurements and things like that, because especially the further you get away from the equator, the worse the distortion is with just a geographic coordinate system.
Yeah.
So you use projections to minimize distortions. So hopefully that helps.
So yeah.
Get the right one for what you're doing. And if you ever have questions about that,
Yeah.
you can either email me or come to drop an hour to set up an appointment. We can talk about that as well.
It's like a whole world of pain, but also it's helpful. It's good to know, because when you are calculating things, it's good to understand like what you're using can have a definite impact. And you might still be able to plot things. Sometimes like Google Earth or Google Maps will use like just a general geographic projection, WGS84, but when you actually want to do calculations, you would want to have a projection for your area. So yeah, I'm not going to wade too much into that because you can get into weeds, but it's important to sort of recognize right up front that that's a definite factor when you're doing spatial work in whatever program you're using, R, ArcGIS, it doesn't matter. It's a something to consider. All right, so let's talk about spatial data. So I'm going to give an example. So there's two main packages, I would say, in R right now that are really useful. And more I'm starting to use the SF package. And I'll talk a little bit more at the R group this week just on SF and some of the cool things you can do. But I'll give a few examples with both RGDAL and SF. And so just to give you an idea, I'm going to walk through some examples of doing XY data, like point data, some line and polygon data, and then a few cool packages that are like interactive mapping, leaflet, and some other things that you can do. I'll show examples of that. And then if you're having problems, which is not uncommon, installing RGDAL or SF, we can help you. So if people are interested in getting these set up and you don't have them right now, like we'll stick around and try to make that happen, because it can be tricky depending on your platform. So anyway, I'm going to show the examples first, and then afterwards we can talk about actually implementing this. So let's load our packages first. And so I'm going to use RGDAL, Tidyverse for the ggplot and a few other things. Viridis is a really great color palette package. SF, I'm going to show how to grab some data, a table off of the web using the rvest package, and then maps and map tools. So these are that's pretty much what I'm using for the rest of the entire tutorial. So XY data. So this is probably the simplest type of thing to plot in R. CSV of sites laying around. You might have an actual shapefile of XY points. That's great. We'll show how to read in a shapefile in a second. But what I wanted to do is use this list of hot springs, California hot springs. That's just this table, because this is something that you'll get a CSV or a table that just has like data in it, and sort of I want to walk through how to get that data in, how to clean it up and make sure that it works, and then how to make a map. And so one of the first things we want to do is just get this data in. And so we can do that with a pretty cool tool in Chrome, but Safari, other things have this. If I right click and go to inspect. Oh, sorry, you want me to show the link? I clicked on this California hot springs bit right here. So if I click on this, it brings up this box. And if I scroll around in here, you'll see different things get highlighted, okay? What's really interesting is if I scroll down and find, I just want to highlight just the table. So there, if I end up on that line, just the table gets highlighted, okay? And if I right click on that and I copy XPath, that's all I need. Then I go back to my code over here. Let's go to the website because it'll be easier to see. Let's see, so I've loaded rvest, which is the package. This is the link, the website table link. Now all we're going to do is read that HTML in, and here's that XPath. So I copied that XPath right in here. All that's doing is basically telling it how to read that table in, so it reads it in as a nice data frame. Okay, so let's try that in R. Okay, so we're going to load our packages. And then we're going to load rvest. There we go. So now at this point, so I've run this to here. Now it's read this in, and I should have a frame over here. And it says it's a list of 1. But you'll see within that list, there's a data frame with 304 observations, and each of those is hot springs. So to undo that, so it's a data frame, it's not a list, I'm just accessing basically here with brackets. Now I have a data frame over here. We've got a nice data frame, okay? And if I click on that, let's view that. There we go. So now we've got XY points, which are here, lat and long, right? And we have locations. We need to clean that up a little bit though, because it's going to be hard to map that. So let's add some names. We're going to set names for our column headers. And then I'm going to, one of the other things you'll notice is in the data here, the temperature is character when it read it in as a type. I'd like that to be numeric so I can actually maybe plot temperatures. We'll change that and then write that to CSV. Okay. Now, one of the things that I'll show you in a second, there's one thing wrong with this table. Can anybody guess? I'll go back to the, let's look at it here. One thing is going to be an issue. It has to do with these points. Can anybody guess what's going on here? I know there's smiles for the people that already see it, but if I plotted this, here's one of these things where projections matter. Latitude and longitude. So longitude right now is positive. So one of the issues is the way that the geographic or projections work is that this is going to map on the wrong hemisphere, right? It's going to, if we plotted this, it wouldn't show up on our map because it would be somewhere in the ocean probably. So the easiest, like right off the bat, whenever you see lat longs and if you're at least in Northern America, you're not going to want to see positive numbers here for the longitude. You want to see a negative, whatever that is. So we need to fix that. And so all I'm going to do here is I'm reading my CSV back in that I wrote just as an example. And all I'm going to do is multiply that column by -1, just so that it will plot where I want it to plot. Okay. I know that was a lot, but that's a little quick example of how you can scrape some data from the web. Now let's actually get to mapping. So let's make this spatial. So let's make this with RGDOL. So I'm using the RGDOL example. Spatial points data frame. So this is a spatial object. Spatial. All we're doing is telling it the lat long column, which is 3 and 2 and 3. And long comes first. Long is the X. And lat is y, so 3 and 2. I'm giving it location, saying that this is basically that's the part that's going to be spatial. And then the second part of this is just saying columns from the spatial bit. Yes, please.
It went fast before.
Yeah.
I don't have Chrome, so should I not be how when I have this with the actual table? Put that in my car. I have to save it in CSV.
So that we scrape the code above actually scrapes that data. If you want here, which I may not have linked to it. Actually save that data on the GitHub repo where this lives. So all this data and the stuff that's on this website is on GitHub here. So I clicked on the little GitHub link over there. So if you go in here and into data, if you want to follow along, this is, wait. No, this is not the wrong, it's the wrong GitHub link. Sorry. What happens when you're trying to do this too soon? So let's go to the right GitHub link. I apologize for that. So mapping in R, sorry y'all. Here's the data folder. I'll fix that link on the website later. And inside of this is a whole bunch of different data sets if you want to play with it. But the one that, which would be ironic if I didn't put it in here. Oh, there it is, Hot Springs. So if you want to grab this, it's here. You can just right click and download it to your computer. It's already cleaned up. So I'll leave this here.
Is that our script that you're showing us in there too?
All the scripts, yeah, everything. So the code, if you click on these little hide code buttons, the code is right here for everything I'm showing you. And
it's not all together.
Each chunk, right. If you want the whole thing with all the the other text and stuff, it would be also in the GitHub under these different pages. So each is an R Markdown. I've done these as an R Markdown. Good question, thank you. All right, so we have that. So now we've read this in as a spatial data frame. So if we look back over in our R, you'll notice now I have this df, or SP is what I'm using for spatial. You'll notice it's a formal spatial points data frame. And it has 304 observations, 6 variables. And you'll notice some other stuff below that. There's all these @ symbols. And that's the way the RGDAL structures spatial data. It sort of puts everything within a list, and there's like lists within lists. And so coordinates are here, there's a bounding box, there's this proj4 string you'll see. Each of those you can access pretty easily if I just say df locks, make this a little bigger so you can see it, and then underscore sp and then @. So now you'll see a bunch of things pop up, right? Data, coordinates, and if I want any piece of the data, let's say I want one column from that data, I would hit data. So now I'm into the data, and any column, I'm going to use the normal R $sign to extract that single column. So you have to use these sort of @ symbols to get into that level of the list, and then within that, you can use $signs to deal with the individual pieces. So you can imagine this works great. It's what the standard has been for a while. But it can get a little, when you're writing code and trying to grab things and do operations within that, it's a little tricky, right? You have to add a lot of where you are in the right piece of that list, which is where SF has been a really nice addition. So I'll show that in a second. So one of the things we'll notice is this proj4. So to check our projection, like I said, we have spatial data, but does it have a projection? We can use proj4 string, and it will tell us that there's nothing there. There's NA, but it doesn't actually have a projection yet. We want to set a projection so that we can work with that in the future. I have 2 different examples. You could do UTMs, but let's use the latitude longitude because that's what it currently is in. That's what it looks like. So lat84, this is WGS84. And again, here's this code I was talking about, right? 4326. So I'm just going to load that. And if I look at that, let's type in lat84. And you'll see it gives me this long string over here. It includes the code, but it also has projection, datum, definitions, the ellipsoid. And then this is sort of what's it stand for? WGS. Anyway, another piece of the projection. So if we want to assign that to our data, so now we just have this chunk of code that tells what the reference is. If we want to assign that to the spatial data, we can do the same thing, but we're just going to reassign we're going to switch basically project4 string. We're going to say that we're assigning this projection to this spatial data. And so if I send that, okay, now let's look. Now I'm going to do the same code I did up here, where it gave us an NA, but now you'll see it gives us that string. So we know it's successfully given it a projection. If you want to transform something, so you want to switch it, if you know it is in something, you want to go to something else, you can use this SP transform, and then you give it the spatial data, and then the projection that you want to go to. Same idea. Cool, any questions? That's there you go, you've got spatial data in, you projected it, now you can map it in 100 different ways, which we'll show a few of in a second. So now that we've done that, let's show the same thing, but with the SF package. So again, I'm going to read in the data. I'm going to fix that weird longitude issue where it wasn't negative. And then the really nice thing about SF is it reads things in instead of this kind of weird spatial data frame. It just reads it in as a data frame. And so the st as sf function is what I'm going to use. Let's stretch this so it's not quite so weird looking. And all that you need to tell it is, here's the data, the table that we're interested in. The coordinates, again, longitude is x, latitude is y. And then I'm going to add a flag here that says remove. I don't want to remove the lat long columns because I might want to use those in the future. And then within that same command, you can actually assign our CRS, our reference system projection, right? And I'm using that same code that we used above. That's it. So it's all one line or one function. And if I send that, let's look over here. So this, I've ended it with SF. So all the SF stuff will end with SF in this tutorial. So let's go over here. And now notice on the right in our environment, we've got, so remember, here's our spatial data frame. But look at our SF. It's just a data frame. It reads it in as a plain old data frame, which is really cool because we can do all the data frame things that we can do in R pretty easily. Joins, intersections, you know, like just operate as you would on a normal data frame. But the main difference is, so here's all our data, right? The main difference is there's a column at the end of any SF object that's it's called geometry. And it's called a list column. So it's taken all the spatial pieces and put it into one column, a list column. And this is the same for points, lines, polygons, doesn't matter. So this list column, like for polygons, could be really long because it could list for the whole polygon, all the points required to build that given polygon. But it puts it in one column, which is great because I can operate on all the other stuff, query the data that I want, pull it out, and then it keeps that spatial data, you know, reference to it. So it's also, I'll show you an example, much faster in reading and writing shapefiles. Quite a bit, so not just a little bit, which is nice. Okay, so any questions thus far? I know I'm throwing a lot of stuff at you all, but yeah.
Yeah, I'm a beginner, so I'm wondering if you can talk more about the projection stuff, why that's necessary.
Right. So I would say the best answer I can say is that you don't need to worry about what the projection is as much at this point, but you need to know that it should have some sort of projection and they should be the same. So if in this case, I want to show, I mean, I'm reading the same data in, so it should plot in the same thing, but they should be the same projection, right? So the projection is an important piece of that spatial data. Without that projection, it's just like making a figure of XY data that you can't really, it's not referenced to a globe, to a given location. So the projections give a way for you to map your data to a given point on the globe. And any given projection could stretch that, like Michelle was saying, you know, if you're doing a calculation of, say, I want to know the distance from point A to point B, there's projections, if you're using them in the right place, that will give you a pretty accurate measure. But if you're using a different projection for those points, that's, you know, a projection for somewhere else on the globe, it's going to be really, you're going to get a really sort of spurious measurement because you're using a projection for a different location. That's the best I can give you as far as I think that's a whole, like that'd be something to sit down and talk if you have specific questions about like what projections are and how they work. Be happy to, there's folks here who can talk to you about that. Does that help? Okay, yeah. Okay, I know it's kind of like black magic. You're like, I don't really understand this whole projection thing. I still don't completely understand projections sometimes, like, what's happening? Okay, so now we have these two different ways to bring data in, these two different packages. Let's make a map, okay? Now I'm gonna use the two packages, maps and map tools, which we loaded above. Those are really nice because they're a really quick way to bring in maps of California, or pardon, state boundaries, world boundaries. And there's another package I'll show called US boundaries, I think, that's really nice for states and counties. So anyway, the simplest command you can give for this is you can say map. And again, this is from the maps and map tool packages. State and a region. And so I'm just specifying California, and if I send that command, there we go. We have a map of California. Okay. Well, I want to add some axes to just get a better sense of where this is. So if I map that, you'll see it's giving me latitude, longitude around that box. Let's add counties. So I'm using the same thing, but I'm just changing the first argument to county. And I'm saying the region is California. And then the other thing I'm doing is adding a few other things to change the line type. Add equals true, which means it's going to add it to the existing map, and changing the color. And so it's kind of hard to see on here. Let's zoom in a bit. So one of the things that you'll notice is that you get these lovely square maps that have all this white space around them when you're plotting. But as a quick way to just check your data, this is a nice way to do it. But I wouldn't use this as a way to like make a publishable map. But you can see very faintly there are some gray lines on there that are actually. So let's add our hot spring data. So we have points, right? So we're using base plot, we're using points to add to our given plot. Here's the spatial. Remember, this is the RGDAL version of our spatial data. So notice for points in R, you would have to say X and Y, right? Typically. Notice here we're not doing that. We're just saying here's the spatial data. You just give the entire spatial data frame, or yeah, spatial points frame. CEX is just a way to shrink the points down a little bit. Point and color. So let's go ahead and add that. There we go. There's our hot springs around California. So that looks like it plotted in the right place. Great. Okay. Well, what if we want to add a legend so we know what we're looking at? Well, let's zoom in a little bit. So how would we zoom in? Let's say we want to zoom in like the Central Sierras, the east side of the Sierras. Well, we can specify with the boundaries using the X lim and Y lim, just giving it the actual lat long. So you just eyeball the map and say, okay, I want to do between 36 and 38 and 121 and 119, something like that. So that's all I've done here is I just added some boundaries. And you'll see now we're zoomed in sort of on the border, the east border of California. Let's add our counties again. And again, notice the counties I had to add, I added the exact same X and Y limbs. So it would plot just those counties. And now let's add our points. Notice for the points, I'm not adding any boundaries because we've already limited our map to that given region. Okay, now we can actually see a little bit more specifically where these are. And so let's say I want to add the names of these strings. Well, remember to access, there's a name column. To access that, I have to use that @ symbol, right? So @data $ column name, which is string name. And I'm using text and labels as the function to do that. And then some color and font-based things. I'm making it bold. So there we go. Now we have some labels. It's not a pretty map, but it's functional. Again, this is just to show you how you do this base, in base R if you want to make a map with your spatial data. And so if you haven't used the legend command before, you can tell it where, and then you list the different pieces that you're going to want to plot, and then you just literally go through, lines or character, point character, the colors, all that stuff is within this every single detail, but there we go. There we've put a legend over the top half of our map, right? But you can see there's a dash line for the counties, and there's points for the hot springs. There you go. And if we zoom, here's again one of the things, the downsides to this way of plotting is this is not a great map, right? I'll show you how to make a nicer one in a little bit. Okay, any questions on that? That's a basic map. We got our data in, we read our data. It is on a map, it has labels and a legend. Cool. All right, can we do the same thing with SF? Well, if we tried to do the same plot, you would get an error that says something along the lines of error in data matrix, list object cannot be coerced to type double. The reason is the plot is actually reading a list. And remember, SF reads in as a regular data frame. It's not a list. So it's actually not, you would actually have to tell it the XY columns like you would normally in a regular plot. But SF has its own plot, sort of plot version that you can use. And the simplest is similarly plot, which I know that's confusing. But with SF package loaded, and if you use plot, that will default to the plot version, the SF version of this. So all I'm doing is the same thing, just the entire data frame. So what happened here? So again, this relates to the same thing where SF objects are data frames when they're read in. It's basically plotting XY points for every single column in your data frame. So each of these is a column in the data frame, and it's plotting an individual plot across each of those. So, which is maybe helpful, I guess, in some cases, but rarely. So how do we just do one? I just want one plot of my points. And to do that, you can use all the SF commands typically start with this ST underscore. So ST coordinates is just going to pull out the coordinates from, remember that list column up here in our, look back in our, here we go. So ST coordinates is literally just looking for this geometry column and just pulling the coordinates out. That's all it's looking for. And so the nice thing is if we wrap our data frame in that and plot, then we're going to get this nice, but it's a plot that's just those points. A little bit kind of stretched, but again, it's plotting our points. One of the things I'm realizing, I have the font. If you're trying to use this code, you might get an error related to the font family, Roboto Condensed. You can go download this. I'm happy to show you, but if something breaks, it might relate to that font. So I'll change that back to just plain old regular font. But if we want to add a title, that's how we add a title to that. Cool. Any questions? Slowly building up to the fancier stuff, I promise. Feel free, if any of it, I'm going too fast. I know I'm going fast, but if you have questions, feel free to holler. Okay. So again, another version of plotting, of making a map with ggmap. So ggmap is another package that allows you to download sort of Google backgrounds for your map, make it kind of look nice. You can download topography or terrain or aerial imagery. And so we're going to, if you don't have that package, you want to download it. And then I'm going to assign a location, which I'm just sort of picking a centroid in the middle of California for this. You could pick whatever you want. It's not mandatory. But it allows me to then use this getMap function and tell it to look for that location. And I'm specifying I want a black and white map, terrain, and the source is Google. There are other ways to pull open source imagery and there's like Stamen maps, and there's a whole bunch of them that you can pull with this. Be aware there are some places you can't actually use if they see the Google imagery in you can't publish with a Google imagery. There's certain copyright rules. Same thing with presentations. Some conferences don't like that, so you need to find there are open source alternatives. So you can do that specify that in some of this. Okay, so let's go and grab that. So if I run this code, you should get a map from URL, blah, blah, blah. Great. So no, you don't see anything, nothing happened. But if I wanted to see that, I can basically use this ggmap call, which is ggmap is mapping this data that we just got. And I'm just calling it sitemap. So let's look at sitemap. Let's just run that and see what we have. Might take a minute. There we go. So it just loaded the terrain topography for sort of Central California, Lake Tahoe area. And now that's my background that I'm gonna map my points onto. Okay, so now we're gonna sort of switch over to ggplot for plotting. And for these examples, I'm only using the SF version. So this is one of the other nice things about the SF package. When you read in, it's a data frame, which means it plays much more nicely with things like ggplot. So you can actually make really nice maps inside a ggplot framework with SF. Whereas if you tried to do that with RGDAL based, it's possible, but it's really not easy. So all I'm doing here is calling the sitemap. I'm starting with this background here, and then I'm adding geom_points. So for those of you that are familiar with ggplot, this is the main thing you need to see, that just geom points, data, and I'm actually just using the data frame and the long lat. I'm not even using the geometry column. That's the other nice thing, is the data's just in a data frame. I don't need to use any abstraction. Just the geom point. I'm using a fancy Viridis color scale in there to make it look a little nicer. Filled by the temperature, so we can see mapping like the color of the temperature of the hot springs, and then adding some labels. So let's see what that looks like. And there you go. Now we have something that looks a little more tangible. If you wanted to share it with somebody or send to somebody a static map, they could really quickly see, oh, well, there's some hot or warmer hot springs in that location. Add something that's like, some of these might be NAs where they actually don't have temperature data, so you might want to add that to your map. But that's a passable map, which is great, and that's in ggplot, so we can save it really easily to a PNG or PDF or anything like that, which is really cool. Yeah.
Are all of your points plotted right now in that frame, or are there points outside of that?
There are definitely points outside of that frame, because I didn't specify. So it's basically just plotting the ones. It'll drop anything that's outside of this bounding box.
Where did it get that bounding box?
From up here, from when I called the. That's a really great question. So when I called this as my sort of centroid, and then the other thing to consider is zoom. So you can change your zoom. And you could zoom out and have all of California, right? Or you can zoom. So I just had this zoom set so you can kind of see some of the details, but that's a great question. So as you sort of tweak the zoom in and out, you'll get more and more points will show up. But anything that's not within that sort of set zoom centroid or location point, it just drops those points. Yeah, that's a great question. Cool. Yeah. Oh.
Is there an alternative to specify the bounding box as opposed to the centroid?
Yes, you can actually give it. I think you can give it an actual bounding box if you want. So you could say like, I want this whole like y-min, x-min, max sort of thing if you want within that function. Let me see here. I know I've done that before. I don't remember exactly how, but yes, I think you can. Yeah. Nope. So let's say aerial. And so it tells me satellite. Sorry.
There's even a watercolor option.
There is a watercolor option. It's lovely. So let's plot now with this. And notice, so here's your question. See how it says remove 255 rows? So remove tells you how many points it dropped to make a map. This is black and white imagery, but there you go. So there's satellite imagery. So you can add that pretty quickly, right? So you could drop that and it's set to black and white, but if I took the BW command out of this, it would give you the full color. So color up here, you could just say color. Does that make sense? So yeah, you can play with it as you like. It's really fun and it's easy. It's nice to like throw into slides and stuff if you want to, you know, map your data. Cool. Any other questions? Yeah.
What if you had polygon data? Does the ggmap know how to use?
We're gonna talk about that. Yeah, ggmap and polygon data might get a little bit tricky. I haven't tried it recently with the SF package. I think you can do it, but let me check on that for you later. Yeah, it's a good question. But that's a great segue because I wanted to show the line and polygon example. So I have two other, I'm gonna just show these really quick. There's KML and KMZ. So for those of you that work with Google Earth or even if you read stuff with a GPS, sometimes it'll output as KML or KMZ. I have a quick example of how to read that in. So one of the great things is SF, again, plays well with this and reads it in. So I have an example here, and the data is, again, in the GitHub. So if you want to try this, you can read in. This is USGS stream gauges for California. And you can read that in just with this st_read. And KMZ and KML are the same thing, but KMZ is the zipped version of KML. So if somebody sends you a KMZ, you can right-click on it with your computer and unzip it, and you'll get a KML out of that. And the KML is what you'll need to run this. So that's something to be aware of. You can essentially just read that in. I had to fix some stuff with the data. You can look at that. I'm not going to go through it, but the important thing that I'm going to show in a second here is there's a nice command called geom_sf in the most recent version of ggplot, which will plot your SF objects in ggplot really nicely. And so again, you don't need to specify anything. You just give it the data frame or the data object, and then it plots it for you, which is great. And so there you go. There's all the USGS gauges in California with a KML file, which is pretty cool. And then here's how I did the same exact thing with a background map. So that's that. And then rasters, which I'm not going to talk about. Kate Tiedemann gave a presentation a week or two ago, and there's a really great tutorial, Neon Data, which is linked here, which they also have a really nice vector-based, like so shapefile points, lines, tutorial in R, which I highly recommend. They go through a whole bunch of nice stuff. They provide the data. You can play with rasters, data and analysis. So I would say this is a better place to start for if you're interested in raster-based data. I'll show a few examples with plotting raster stuff, but this is a really great tutorial. So I'm not going to really cover raster stuff today. Cool. So let's go to the polylines and polygons. Any questions so far? Just information fire hose. All right. So let's do the same thing. I'm going to just show the same like RTDOL and SF, and then sort of move forward with SF. So let's make sure the packages are loaded. Again, the only new one here, or a few new ones, I guess I'm adding, are USA boundaries, which again is that one that pulls shape files for state and county boundaries. IMAP is a nice way to play with your color functions and add transparency and stuff like that. And then ggRepel is a really nice, you can use it for not just mapping, but is a great package for adding labels to ggplots, and it will space them out for you, so you don't have to, it'll automatically like put lines and arrange them so they don't overlap, which is great. And for this example, I'm using this HydroShed data, which has a whole bunch of really cool, globally, information on lakes, streams, and watersheds, boundaries. And you can download it. It's all free. You can just log in. I think they ask for just an email. But it's freely available, and it's global. And it's actually surprisingly good. So I work in water. I work at the Watershed Center, so my examples are all relating to rivers and water. But you can play along that way if you're interested. And I've added this data on GitHub. Hopefully the right link is here. So if you click on that link, yeah, and then just download this zip. I downloaded just California and Oregon rivers for this example. So that's linked here on this little chunk. So let's see how to do this. Let's read this in RGDAL. One of the things you want to do in RGDAL is oftentimes, I usually, before you try to load something, because it can take a while, is to load this with, look at the info to make sure it works. Use OGR info. And then it's gonna, most of these commands for shapefiles will ask for two different things. They'll ask for the DSN, which is typically the folder, the directory where this stuff lives, and a layer, which, notice this doesn't have an extension, a file extension. It's just the name. For those of you that know shapefiles, you know there's like 4 or 5 different files that all have different extensions, right? So I'm just using the file name and not the extension. And so if I run that, let's switch over here. And let's run this so we can see. So when I run this, it gives me, pretty quickly, it gives me info on this data, this shapefile. And it's actually telling me, the nice thing is it tells me the reference system. So it has one, which is good. The extent is your bounding box. If you quickly wanted to grab your bounding box, this is essentially the extent of your data. And then all the other attributes associated with that file. Number of rows, so there's 21,976 records for streamlines in this, and then all the other stuff. So that's nice, so great. So we have this great data set. So let's do the same thing, but now we're gonna use read OGR instead of OGR info. And this is actually reading the file in, but it's the exact same as that. And again, I'm gonna call everything _SP for the spatial RGDAL stuff, and SF for the SF stuff. So notice I'm gonna send this right now and see how long it takes. So it'll read the first part and then it's sort of gonna take a few seconds or more, still thinking, and thinking. And this is to be fair, okay, finished. So this is a fairly large file. There's a lot of pieces. If I look in my environment, you'll notice now I have rivers _SP. It is a large spatial data frame with 21,000 elements, and it's actually 40 megabytes in size when it read this in. So it took a while. That was a good 10 seconds or so. And I can check projection with this, again, the same thing, proj for string, just to make sure it has one. Great. It's WGS84. Okay. Well, let's do the same thing with SF and see how long it takes. And for SF, it's just the st_read. Notice again, I'm not adding the extension the .shape or anything. It's just the data and the layer. Done. It's read in that quick. So you can imagine I've read say a gigabyte size file in, and it took maybe 15 seconds with SF, and it took close to a minute with, or more than that, with RGDAL. And that's across the board. It is just fast, and it's really nice and clean. And I love the fact that it reads it in as a data frame, because you can do a lot more. It's a lot easier to work with. You can write it out as a CSV if you just want the data and not have to worry about the spatial stuff. It's great. Not that you can't do all that in RGDAL. I just find that it's a much cleaner package for working with spatial data. If I want to check that reference again, there's a command st_CRS, coordinate reference system. So if I want to make sure, yep, there you go. Even better, it actually gives me the EPSG code for this projection, which is nice. Okay, so that's the process for reading in polygons or lines or anything like that, right? So a polygon would be the same process. So I'm not going to really show that specific example, but I do want to show you this other package that I mentioned, the US boundaries. Hang on, let's clear our package for a second. So I do want to show this USA boundaries example because I think it's nice if, for those of you, how many people actually work with like state or county boundaries? Sweet, a few, 3, okay. I think it's nice. And there's a few different packages that provide this, so this is not the only one by any means. But it's USA boundaries. So this is the package up here. And same idea, you can just list a bunch of states that you want, or the whole US, whatever you want to do. I'm just going to use California. And then it has high and low resolution, which gives you sort of like the detail of the outlines if you really want high detail or low. And then you can set the coordinate system transform. It comes with a coordinate system, which I forget what it is, but I'm putting everything in the same WGS84. So you'll notice when this reads in, here's the other nice thing about this package, is that it is SF based. So now I have, you'll notice a data frame, California here. Notice it's literally one row. If I click on this, it's one row because it's just a single state. And again, this is a polygon. So let's look, it has all these attributes. Area of land, area of water, state name, abbreviation, jurisdiction. Here's my list column at the end, that geometry. Notice it's a list with a list because it has the list of all the points around that polygon. But it's a really nice, clean way to read data in. So that was great. So why don't we read some counties in? So same thing, I'm just listing a bunch of counties. And then I'm using the US_counties command instead of US_states. Read it in. And the other thing I'm doing here, I'm not going to talk about per, but per is another package that you can, it's kind of like apply a function to a list. And so it's a really nice way. In this way, I've basically filtered from all counties to just the ones I want. And then I'm actually adding the centroid of each county to the data frame, which is kind of nice. So I'm adding a longitude and latitude that is the centroid. And there's this great command called st_centroid, which just grabs the centroid for your whatever data you're working with the polygon. And then you can use that for label. I'm using it for labels, right? So the label at the centroid, which is nice. So that's the map, and we had a per tutorial that Brandon Herr gave a few weeks ago that's also up on the DRUG website, which is awesome. The more I've been using it, the more I've been really impressed. Here's another thing that I do a lot now is I set a range for my maps. Again, this is like that xlim, ylim, but I'm actually using range and then grabbing the coordinates from my SF object. So in this case, these are the specific counties that I just downloaded. And I'm just saying I want the sort of xlim and ylim for each sort of that whole set of counties. And you can use that, I'll show you in a second, to make your maps a little bit nicer. So here's a silly example, but just to show you the same, we read in RGDAL and SF, just to show you that they both work the same way. Here's plotting with the RGDAL way, and here's plotting with SF. And I've noticed I've added this st_geometry. The only difference between those two, they should be the exact same map. Turns out they are. It takes a second because these are a lot of rivers. But there you go. Voila. Okay, so with SP, with SF, it's the exact same thing. Going forward, I'm pretty much just going to show SF, just because it's shorter and easier to do. Yeah.
With the SF object, do you have to do the geometry command so that it knows it's not a data spatial object?
No, so the ST geometry, remember when I plotted and it plotted every single column?
Yeah.
That's the only, it's just plotting, because it's a data frame, it's actually it's sort of forcing the data frame and reading as a list. And it's just it's going across every column in its list of columns, essentially. So ST geometry just says, nope, I just want the geometry column. I don't want any other column. Yeah, that's a good question. Okay, So let's start layering. Let's do some nicer things with mapping, and let's start layering a few different pieces. So let's map our. I'm just using the base mapping with the ST geometry function that we talked about. I'm adding the counties, and then let's add the rivers. See what happens. So that's it's mapping a whole chunk of rivers on top of our counties. And if I wanted to add labels for my counties, and again, I'm using the long lat column that I made, that's the centroid, just to add my county names. There you go. So here's a map. It's not very good because it's really hard to see what's going on here because the rivers, there's a lot of ink being used over here if I'm only interested in this. So how can we fix that? One of the nice things you can do is with ggplot or layering is you can sort of put certain things first and then layer on top of that, which is one way. But in this case, we actually, realistically, let's say I only want the stuff that's in these counties. I don't care about this. I want to get rid of it. I want to crop it out, right? So here's one of the awesome things about the SF package is it has all the same functionality that ArcGIS does, where you can clip, crop, intersect, join, all that stuff. It has these great functions for. So I'm not sure what is this the same plot? Let's see. Oh, I just added a bounding box and changed the font color, but it's the same issue, right? We have all this other ink here. So how can we get rid of the extra rivers? Well, there's a really easy command called st intersection. And the SF also has 4 or 5 now really nice vignettes that actually go through all their different commands and give examples that I highly recommend that show all the different things you can do. I'm just showing a few that I've used a lot lately. So st intersection. So all I'm doing with this is I'm saying that for rivers SF, that's the stuff I want to crop. I want to crop it by the counties. That's it. St intersection, rivers, crop by counties. And reassign, I'm assigning a new object called rivers crop. Now I run that, and here's the other cool thing is it's really fast. And so it will give you a warning. And it's, again, this relates to projections. So it will do stuff, but we'll just let you know, like, hey, coordinates are longitude, latitude. ST intersections assume that they're planar, that they're, on a flat map. Attributes are considered spatially constant, yada, yada. It basically did what we wanted, but if all your stuff is in the same projection, you don't have to worry about that. It's just giving you a quick, hey, did you check your projection sort of warning, which is nice. So let's check that this worked. So let's just do the same thing. Let's just plot that rivers set. Voila. We can see it's a much smaller blob on our screen. It's really hard to see. There we go. So you can see that's the exact outline of our counties. That's it. And I find this just so handy and really nice because you can make lots of different things with this. You can crop, you can merge, so you can dissolve stuff the same as you would. All those counties. The other nice thing is this automatically, even though it had multiple counties, right, different polygons in that, it just crops to the total outline. Whereas in GIS, if you try to do that, there could be some issues, right? It's going to yell at you because you'd have to dissolve everything first and then do your crop. You can do buffering. You can do a lot of different stuff. So, okay, so now let's do our plot again. And essentially, I'm just doing the same exact thing as before. Here we go. That's not bad. I've added the state line so you can actually see the California boundary, but you get the idea. All right, well, that's in base plot. So this is still base plot. What if we want to do this in ggplot? Again, we can do some other nice things. ggplot, the newest version, has a geom_sf, which is just plotting SF objects. So let's take a look at that. And let's plot the uncropped version first. So I'm just calling an empty ggplot. I'm plotting my California SF object. Then I'm plotting my county's SF object. Then I'm adding labels with this geom label repel, which is that one I told you about. GG repel was really nice because it'll fix your labels for you so you don't have to mess with them. So let's take a look. There we go. So this is all of California. And notice that it's kind of stretched these labels out for me so that you can mostly read all of them. That's just an example. So now let's do the cropped version. So let's say we want to use the state boundary. I'm going to use the county boundaries that we used. I'm going to add the labels, same as before. Here's the only difference that we're doing now. There's a coordinate or coord_SF, which is where you can add your map range, that bounding box that I was talking about. So xlim and ylim. And the nice thing is by using this sort of map range command that we did earlier, that gives you a way to just basically say, I just want to plot this piece right here, this bounding box. And then add some labels. And so we run that. There we go. Now we have a much cleaner, nicer map. It is fairly legible, and that, you know, if you wanted to overlay hot springs on that, you could, or whatever you want to do. So that's that. Are there any questions about plotting the ggplot or SF stuff? No?
You want to put a base map under that? Did you show how to do that in ggplot, or is that?
Yeah, so that's ggplot. So you could use the same ggmap. So you would start with your ggmap as your base. Okay. You know, the one that we call, like you could say, use this bounding, the centroid, or whatever it is that you want to use for your ggmap, and then you add all this stuff. I will say I wrote a blog recently that at the moment they're trying to update this, but I know ggmap and geom SF are not necessarily playing well together right now, so bear that in mind. So I might need to check on that for you. Okay, if there's no questions, I want to show you some of the cool new mapping methods that are available. So that's basically how to get your data in, and similarly you can write, I haven't mentioned this, but SF package, you can write out anything that you want. So you can write out as a KML, as a shapefile, as a CSV, whatever it is. They have a whole list, and it's literally st_write. And you just say, here's the data frame, here's what I want to write. And as long as whatever projection it has, it'll keep that, which is great. So it's same thing, really clean and easy to use. Cool. So let's look at a package called tmap, which is pretty recent. And the nice thing is this is a framework similar to ggplot. And I just want to show you a few different, this is straight out of their, this works with rasters as well. This is straight out of their tutorial. They have some data on Europe, and then this QTM function, which is like a quick map, and it will plot essentially a shapefile. What's really nice is there's a lot of really fancy things you can start doing. So if you have a polygon, again, these are just shapefiles. This is the name of the polygon shapefile. You can add some text and then format it, and you can make some really nice maps this way. These are mostly, I would say, the TM or tmap package is largely for static maps. So we're talking about rasters and vector-based stuff that you want to maybe print or put in as like a PDF. But here's another example with a raster. So this is a TM_raster with a shape, more shapes, TM lines, TM shapes, TM bubbles, and then text. And so you've sort of layered a whole bunch of things in the same type of way as ggplot. And it's sort of based on ggplot. And then there you go. Really nice. Here's the other cool thing. You can do faceting, which is also really handy if you want to facet across a certain category or a certain column. You can do that really easily. And the nice thing is options to sort of, instead of adding the coordinates for everything, or adding a legend for every single one of these nodes, like, okay, we only need one legend. it will do that, which is also kind of nice. And then I think one of the coolest maps I saw recently, this one allows you to actually add in the legend a histogram of your raster data. So it gives you like this, and then your data for the world. And then if you want what I call an old school map, because the projection is one of these projections that's not used all that regularly anymore, but you can see, you can now not only make sort of this curved version, but you can actually add a compass, you can add a scale in your legend, which is nice. And so this is also really cool. I mean, that's kind of a nice way to make a, so Tmap. So you want to check it out, check out the Tmap package. Let's talk about Map View and Leaflet, which are really newer packages, which are really cool because they're interactive. So Map View is based on, it's using Leaflet under the hood. And same thing, there's a lot of great vignettes online that you can check out. I linked to here. But you load the package, and then this data is just spatial points. It's just points data. And the cool thing is this is all interactive. So if I hover on one of these, if I click on it, it brings up the entire attribute table for that point, right? And then you can change the layers. So you can add different mapping layers to this, zoom in and out, you know, like an interactive map, which is nice. And this is all shared. So you could share this as just an HTML file to somebody, and they'd be able to, with the internet connection, they'd be able to surf around and look at your points, which is pretty sweet. So there's a whole bunch of functions within this, and the nice thing is it supports SF, only XY at the moment type data. But it's really handy for the following reasons. They can do a lot of things now with these just simple functions. So slide view. This is something that I see a lot now in ArcGIS. They have the ability, you can sort of slide between two different landscapes. You know, like same image is taken 20 years apart or something, you know, forest fire. And it's a slick way to view data. They have built that in so you can do that in R now with the map view. And what's cool is if we do that, I have to scroll down, it's like buried in here. There we go. So, sorry, it's hiding. Come back. So I don't know if you can see, but as I scroll back and forth, you can see this is two different time periods that this lake is largely dried up due to drought. And this is a raster. This is just two different rasters. And it's lined it up, and literally there you go. You can quickly scroll back and forth and see sort of what's changed, which is pretty neat. And this is the code. The code is all here. This is from their tutorials. So check it out. It is pretty neat. I wonder why it's zooming like that. It's interesting. I don't know. So that's slide view. The other nice thing is you can do this thing called cube view or sync views. So say you had a bunch of different maps that you wanted to show someone, but you wanted them to sync up. So if you did something in one map, it would do it in all the maps. So in this case, I have 4 different layers with different sort of data being displayed on each, or displayed in different ways. And if I zoom in on any given spot in one map, it does it for all of them, which is cool, I think. So I don't know necessarily specifically how you might use this, but it's one of their newer mapping. And you can change the way it syncs. So say if you wanted to sync just 2 of these instead of all of them, you could do that as well. So you can imagine doing that for a couple, and then one stays static or something like that. So that is the map view package. And let's look at Leaflet. Is another same kind of deal. I just have one example of Leaflet based on some stuff I did. I use Leaflet a lot, and it's becoming really easy and much nicer. It plays well with SF, it plays well with spatial data, anything like that. And the cool thing is you can really customize it as you like. I only have 2 layers on here, but there's a whole bunch of open source layers. You can make like your own watercolor under layer. I think, did you give a talk? Yeah, that was, I was gonna say, I've seen people making like pirate maps and stuff. It's cool. So you can, Michelle has a talk actually linked on the DRUG website showing some of how to actually get into the, once you sort of have your leaflet, you can get into the HTML and start tweaking it to make it look however you want it, really. One of the newer things that you can do as well is add these measurement bars, which is kind of nice. So you can actually, I find this really handy if I just need to quickly sort of see my data, I zoom in, and then I want to measure, say, between two sites. I can just, in here, quickly like click on a point, click on another point, and it gives me, okay, that's 5,000 meters. So it's 3.24 miles. You can do a polygon, so it'll give you an area. So if I keep measuring, it will give me that. You can actually specify what kind of distances you want it to spit out here in the code. And this is all on the leaflet website if you want to look at that code. So pretty nice. It allows you to do this. You can save these or not if you want, but it's just mainly exploratory. I think it's a nice way to share data for folks. That's leaflet. And the commands in here, I've shown how I made this map and the palette, so you can assign a color palette. And this is using just some point data. So, but it does work with polygons as well, so polyline polygons. And then finally, the one other thing that I've seen a fair amount recently is these hex bins. So if you have a lot of data that you want to sort of display, this is based on some stuff people were looking at US state data. You can download, I provide the link to get this. This is a GeoJSON file, which again, SF reads in just fine. But you can play with that, and then you can map the colors or the sizes of the hexagons based on a given variable. And it's a nice kind of way to display, because you can imagine, you know, California and Texas are huge, and so they can really dominate a map if what you're trying to get across is something more broad in the sense of a trend. Or another nice one I saw was the electoral college displays, right, where they sort of shrunk these hexagons by electoral college size or colored them. And it was very easy to see right off the bat, versus if it was the whole state map, can be a little distracting. So this is just some data based on the mean number of days with frost. So if you like cold, you don't want to move to North Dakota. So yeah, so this is another way to display some nice data. And then that's about it. I have some resources here. This website is a work in progress, so grain of salt. There's errors, as we've seen. But there are some really nice little tutorials and things that are linked here, some stuff just on data visualization. Kieran Healy's new book on social science and data visualization is great. And Carl Broman has a couple really nice talks on how to display data badly, and like why is it bad and how can you make it not bad. And then some more general R books on data science, which I think are excellent. So I know, but the point was to sort of give you a really broad overview, and hopefully in here, buried in here, there's some tools and tips and code that you might actually use and just to be aware of. Because I would say literally in the last few years, R has really started to make a jump from being sort of like, it's just something that maybe some people do some maps in, to actually being a valuable tool that you can do spatial analysis. I mean, I should caveat that. There were people doing spatial analysis in R and have been for a while, but I think it's becoming now easier for people to actually jump in and use these tools and actually make really nice maps or do really nice analyses pretty easily. So one thing I wanted to show you, I've written a few blogs on mapping and with SF using rivers. And so there's a bunch of code and examples in here. But one of the other things that I found really fun recently, where is it? Oh, animated maps in R. So you can actually animate, so this is using ggplot, and this is actually an older example using rgdoll. But I walked through the code to make a GIF that basically flips through a whole bunch of NDVI meadow data across California. And it's pretty neat. The code is all here, the data's there, and it's using these two packages, Magic and Image Magic. And so you end up with this pretty neat terrain, but then it's flipping through each of these, and actually I should scroll up a little. The year is being displayed up here. So this is 1884, 1984 through like 2015, and this is the sort of maximum growing value for meadows, certain meadows in the Sierras. And so it's a nice way to display data. I think it's kind of fun if you do have time series sorts of data that you want to display. You can make these little animations pretty easily as well. So yeah, anyway, that's all I got. If anybody has questions, again, I'd be happy to, if people are trying to get stuff set up, I can try to help, or Alex or Michelle, I'm sure are savvy with some of this as well. So cool. Yeah. Yeah. Yeah.
I was wanting to put interactive maps inside of PDF, where when you print, it's a data out, but then you do have the electronic.
I don't know if that is possible. I know that you could.
All the R markdowns are all
Right, yeah, so they're HTML. So what you could do is just provide a link to the HTML that then people could like open and surf around in. That's probably what I would do, and have a static image. You know, you can make the static image actually linked. So it displays a static image, your map. But then if somebody clicks on it, they would go to their, you know, HTML. Because do you know if you can even do that? PDF?
You can embed JavaScript in PDFs now, but I haven't really tried to interact, because usually that still applies to internet connections. So
right. Just yeah. Sort of the workaround, because I think more people that would work. Yeah. It would also. So the other thing to consider is, like, one thing I've noticed with the leaflet maps are great, but say you have a bunch of data layers and it's a lot of data. The leaflet, the HTML size will be quite large. I mean, like, it could be 100 megabytes for this, you know, map of California with a whole bunch of stuff. And so you can imagine sharing that with somebody, or like trying to embed that in a PDF. People would just be like, no, I'm not going to open that. Like, you know, so if you can sort of streamline and like put it somewhere else, that would probably make it easier for people to be like, oh, I'll just, you know, click on it. Yeah.
Unless you have a huge case for offline internet access.
Yeah.
That's different.
Right.
And then in your case, where you're talking about there, I would actually look at moving your maps, if they're that big, to a service that's geared towards posting those.
Tiling or something. Yeah.
Because if you do have a leaflet map and you do have 100 megabytes of data in it, it's going to actually stream all of that to the browser.
Right.
Unless someone has a lot of RAM, it's still going to bog down.
Yeah.
And so there's a couple of companies that specialize in optimizing, where they only send little bits of data as needed, and they come up with really clever workarounds. And so I can give you a reference for those if you want to make a web map that has tons of stuff in it.
Very awesome. Yeah.
This is for prototyping and exploring, not putting it up for mass consumption in any way.
Right.
Mass consumption being either consumption of mass amounts of data or lots of individual users using small amounts of data. Either of those I can call a mass consumption.
Right. Cool. Any other questions?
I got 15 minutes, so everybody can hack away for 15 minutes and try and break stuff.